We have some angle congruency properties. These properties are angle, angle, side. Side, angle, side. Side, side, side. Angle, side, angle. And hypotenuse leg, which used to be known as angle side, side. Okay? Angle side, side only works when it's right. Okay? It only works when it's right. That's why we use hypotenuse leg. Okay? After that, we'll talk about what's called the reflexive property. Alright? And I should probably remind you about the identity property. Okay? Let's do this. Angle, angle, side. Meaning, if I have an angle that's congruent to another angle, and another angle that's congruent to another angle, which is preceded an angle and an angle, then a side, which is congruent to another side. That means that these two triangles are congruent. Angle, angle, side, angle, angle, side. So they have to follow each other in that order. The two angles are congruent. The two angles are congruent. The sides are congruent. They go in that order. Okay? Now, they could go in this order, counterclockwise, or actually that's clockwise. Well, one's clockwise, one's counter, so. Next, side, angle, side. Meaning I start with a side, then I hit an angle, and then I hit a side. Now I got to do the same thing over here. I start with a side, then I hit an angle, and then I hit a side. Okay? Side, angle, side means that these are congruent. Alright? Can I have side, side, side? Well, yes, you may. Okay? So one of these is congruent to the other, another is congruent to another, and then the last one is congruent to that one. Boom. Now I know that I have congruent triangles. If all the sides are congruent to another side in the other triangle, that means the two triangles are congruent. Okay? It also means that the angles opposite of the sides are congruent. That's the whole purpose of that congruent triangles, right? All right. Next. Not doing well today. Angle, side, angle. Some angle, a side, and an angle. Okay? And then I have to have the same thing. It could be an angle, and a side, and an angle. It just has to be angle, side, angle. I know we've been going kind of backwards towards each other the whole time. It doesn't have to go backwards. It can be the same way. It could be, I mean, these don't look the same, do they? The way that I wrote them? But it's the math. The picture is wrong. Right? Now I know that it must be like that, right? The picture was wrong because once they tell us that these angles are the same, and these angles are the same, and these sides are the same, then I know that these two triangles are congruent. The pictures may not make them look congruent, but it's the math, it's the labeling, right, that's telling me that it is. So therefore, these are congruent. In geometry a lot, they mess with you by making things look like they have right angles. If they don't tell you that they are, And you don't know if they have a right angle or not. Okay? It could be 91 degrees, not 90. So it might just look like a right angle. These walls look like right angles. I guarantee you, most of them are not. Okay? It is very difficult to build a structure with perfect right angles. Okay? You're usually off by about 1/16 of an inch, meaning they can be off up to 1 degree. Okay? So, it happens. It's okay, they still look right. Now, speaking of right angles, these are given as right angles. That's important because across from that right angle is what we call the hypotenuse. Okay? Across from that right angle is called the hypotenuse. Okay? And the hypotenuses in this HL, they have to be congruent. The other thing that has to be congruent is a leg. Doesn't matter which leg, it can be these two. Okay? But a leg has to be congruent. If we have a leg and a hypotenuse, right? Then we have what's called hypotenuse leg. And that means that these two triangles are congruent. Alright? Lastly, but not least, we have the reflexive property. What the reflexive property says this, that BC is congruent to CB. Notice how they reflect? They reflect each other in the mirror. Right? They're the same segment. Of course they're congruent. But we have to have a rule for it. Now this comes back to our identity property from first semester, or first test. Identity property says that BC is congruent to BC. Right? That's identity. So you can use either or, and you're going to be using them a lot. Okay? So it's either BC is congruent to BC or BC is congruent to CB. Either way, they're congruent, we're good. Okay? Now, if these are congruent, which they are, guaranteed, and what if they told us that, I don't know, let's say that, I don't want to presume anything, so let's say that, well, we're not going to, well, we could. Let's say that they said that this was congruent to this one, and that this one was congruent to this one. Okay? What if they said that? Well, once we know that the reflexive is there, and we know that AB is congruent to B, to C, to DC, right? AB is congruent to DC. Why? Because it was given. They told us that. All these red ones are given. AC, right, Kiko? AC, which one is that congruent to? Which one is this one congruent to? On this side. Don't say I don't know. Come on, brother. That has 3 lines. One of these kids has 3 lines. Which one is it? Well, then you should scoot up. B or D? BD. Very good. It's not hard. This is not rocket science. We're just lining things up that are the same. That's it. So once I know that I have this is congruent to this is congruent to this, and these are congruent, right? Then I can choose the triangle ABC is congruent to what triangle? Triangle A, right? What angle is this congruent to? Isn't that the same place as D? A is between the 2 and the 3. D is between the 2 and the 3. Right? A, B. B is across from 3. So across from 3 is 5. Right? So this would be A is to D, as B is to C. Right? And which only leaves one more, right? DC and B is to, right? A, B, C. C is the B. So orange or, yeah, orange. C, A, B, C. 3 is across from 2, right? So what's across from 2? 4. And that's where these colors really come up. So that's B. Okay? So I know that this triangle, right? ABC is congruent to DCB, right? And why? Why? What do we have? We have side, side, side. Right? Side, side, side. We have all the sides. Now, on a lot of that test, I'm not expecting you to do this proof except in problem number 10. All I want you to be able to do is go, oh, I noticed that you have side, side, side. It's side, side, side. If I notice that you have angle, side, angle, it's angle, side, angle. If I notice you have angle, angle, side, it's angle, angle, side, and so forth. Okay? So you're just lining up, see what you got. You have 2 angles and a side, and they go in that order. Right? They have to go in that same order, and you're good. Okay?
There's like